Okay, so we're beginning by looking at solving quadratics by factorizing by looking at a difference of two squares example. Okay, so what does that really mean? The difference of two squares is where your quadratic, this part here, is in the form a squared take away b squared. So you can see here we've got something, so something squared, we've got x squared, take away something else squared, or 9 is the same thing as 3 squared. So if you're quadratic, so if you can see a square part to your quadratic and it's in this form, a squared take away b squared, you can factorize it to go in the form a plus b, a minus b. What does that really mean? It's just saying, well, if we go and look at, well, what's the a part? What's a going to be equal? In our example, so what's your number being squared? Well, that a is going to be equal to x. Okay, so a is equal to x because we're squaring x. And what's your b part going to be equal to? Well, b is equal to something squared. 3 squared is 9, so your b part is equal to 3. So simply, when you factorize your quadratic in difference of two square form, it's going to go into a pair of double brackets. So it's going to be a bracket, a bracket, and a bracket, and a bracket. And it's going to be equal to 0 because solve means you've got to put your quadratic equal to 0 to find your missing values. Okay, so it's going to be a plus b. What your a value is simply x and b is 3, and you're adding them, so it's going to be x plus 3, so x plus 3, and then we've got a take away b, where again a is x and b is 3. This time you're taking them away, so it's going to be x take away 3. So basically you just root whatever this first part is to give you x, and the first part of both brackets, you then root 9 to give you 3, and you plus 1 and you take away 1 to give you your brackets. Okay, and of course, how could you check your answer? How could you, so to make it really clear, this part here, this x squared take away 9, means exactly the same thing as the part below, just this is now into factorized form, and this is expanded form. Okay, they mean the same thing. If you wanted to check that that is factorized correctly, you could go and expand your brackets. Okay, you could go and do x by x, which is x squared, x by negative 3, which is negative 3x, and then the 3 by the x gives you plus 3x, which is why these two then cancel, and then you get the 3 by negative 3, which gives you minus 9, which is exactly x squared, take away 9, what you've got up here. But of course, you don't need to go through it. That's just showing you could check your answer if you're sort of new to all of this stuff here. Okay, so good. We've now got two equations that we need to go and solve. We've got x plus 3 being equal to 0, and then we've got x take away 3 being equal to 0. So you're just trying to find the x values that make this quadratic, okay, equal to 0. So your first one is going to be when x is equal to negative. What am I doing? So I'm skipping a bit of a step there. Sorry. The first one, right, is when x plus 3. So you've got x plus 3 being equal to 0. And then what number at 3 is 0? Must be minus 3. So your x value, one of your values is going to be negative 3. And then your second one is when x take away 3 is equal to 0. So you're saying, well, when x take away 3 is equal to 0, add the 3 to both sides, and you're going to go and see that your x value is equal to 3. So the two solutions, or the two roots of this quadratic equation, are x being equal to, make it in yellow, x being equal to negative 3, and x being equal to 3. Okay, so these are your two solutions. So it's just saying if you were to put in negative 3 or 3 into your quadratic, it's going to equal to 0. So negative 3 squared, if x is negative 3, is plus 9. 9 take away 9 is 0. Similarly, when x is equal to 3, 3 squared is 9, take away 9 is also equal to 0. So these things here are my solutions, or my roots of my equation. So these are my solutions. Okay, or you could call it the roots of your equation. So it's just spotting, right, this quadratic is in completed square form. So let's look at a few more examples. So solve the following quadratics. Okay, so the first one, again, you've got to be able to recognize that these are both in the form a squared take away b squared. So you've got a square number, in this case x squared, take away another square number, which means it's going to factorize to go into a pair of double brackets, where you take the root of the first number and you plus on the root of the second number, and you take away the root of the second number. So in this case, well, a is going to be equal to the root of x squared, so a is going to be equal to x, and b is going to be equal to, well, 16 is equal to 4 squared, so b is equal to 4. Therefore, your quadratic is going to go into a pair of double brackets being equal to 0, where your first part a is equal to x, so a plus b, so x plus 4. And then your second bracket is just the same, but then you don't plus them together, you go and take them away. So x take away 4. And then from here, you've got these two parts that you can go and solve. So x plus 4, x minus 4 being equal to 0. The first one, x plus 4 being equal to 0, x is simply negative 4. And similarly, when you've got x take away 4 being equal to 0, add that 4 on, you get x being equal to 4. And these are my solutions, or my roots to my equation. So when you get a quadratic in a difference of two square form, you're going to get the same answer, one positive, one negative. Okay, so you can now try the your turn. I'm going to go through this one now. Okay, this one, you just got to be able to spot again that it's in the correct form. So this is in difference of two squares form. You've got something squared to take away something else squared, which means, again, it's going to factorize to go into this form, where in this case, again, your a term is simply going to be x, and your b term is going to be equal to 11. Okay, so if we go and put this into a pair of double brackets, there we go, equal to 0, well, your a part here is x plus 11, and then x minus 11. So you pretty quickly get in the routine of just being able to find, put it into the brackets. And then we're going, when this is equal to 0, when that's equal to 0, and to be honest, right, these ones are really quite simple to solve. You don't need to go and write out this line, that's just showing you what is going on. So what plus 11 is equal to 0, x must be equal to negative 11, and then similarly, right, what take away 11 is 0, x must be equal to 11. So these are my two solutions in this question. Okay, two more questions to go. Sorry, I'm getting a little bit overheated. We've got these two here. Again, just be able to recognise, right, these are in the difference of two squares form. And they are, even though they look a little bit different, they're just a bit trickier, but they're both in the form a squared take away b squared, because, well, this first number here, in this case, your a is going to be equal to 3, because 3 squared is 9, and your b part, you've got a 16x squared. Well, 16 is equal to 4 squared, so 4, and x squared is equal to x times by itself. So the root of 16x squared is 4x. And we now know that, of course, this is going to go into a pair of double brackets, okay, where you've got identity a plus b, and then a take away b. Let's go and do that down here. So double brackets being equal to 0. Your a part is equal to 3. Okay, so 3 in both cases. It's going to then be plus b. b is equal to 4x, and then you take away b over here. So take away 4x, and there we go. And then, of course, we've got to go and solve it. We've just factorized it. So this first part is just factorizing it. We then go and solve each part of the quadratic. So the first part is when 3 plus 4x is equal to 0. Take away the 3, divide by 4. X is going to be equal to negative 3 over 4 is your first solution. Your second one is where 3 take away 4x is equal to 0. We can add on the 4x, divide by 4. So x this time is going to be equal to positive 3 over 4. So these here, these are my two solutions. Lovely. On to the last one. Again, difference of two squares form. You've got something squared. You've got 2 squared, take away the 3x all squared. Okay, so that's going to go into the form a plus b, a take away b. So we can go and say that a is equal to 2. B is equal to, well, root of 9 is 3, root of x squared is x. So it's going to go into, again, a pair of double brackets. There we go, being equal to 0, where a is 2, plus b, so plus 3x, and then a, which is 2, take away 3x. There we go. Again, of course, you could expand your brackets and you would get back to this if you want to check that is correct. That's just factorizing it though. You've got to solve the equation, so you've got to now go and find this part. So go and take this part, put it equal to 0, and this part, put it equal to 0. So 2 plus 3x being equal to 0. If you go and solve this, let's move my pen pad out of the way. There we go. Take away the 2, divide by 3. X is going to be equal to negative 2/3. And then similarly over here, we can go do the same thing. We're going to get x being equal to 2 over 3. Okay, if you go and solve that equation. So negative 2/3 and 2 over 3. Just something to look out for. This here is actually, right, this is not in the difference of two squares form, because the first part is not a squared, because how would you get to 5? Well, without, there is no whole number that makes 5 if you square it. So this is not in the form a squared to take away b squared. It is not in this form. Okay, so we're not using difference of two squares, it's just recognizing that some quadratics actually are much more simple to factorize, and we're using methods we learned much lower down the school, and it's just recognizing that. So here, factorize and solving it just means, well, we can see an x in both of our terms. We can go and take out an x, put it into a bracket, and say we've got, well, 5x, and then take away 3 is equal to 0. So in this case, I've literally just factorized out an x from each term of my expression here. So there's nothing fancy going on, but just being aware that sometimes quadratics are much more easy to factorize than we think. So your two solutions are here are going to be when x is equal to 0. That's your first one. So when x is equal to 0. Your second one is when 5x take away 3 is equal to 0. So you can add the 3, divide 3 by 5. X is going to be equal to 3 over 5. Okay, so these are your two solutions. In this case, this is not the difference of two squares. It's just recognizing, you know, sometimes it is easier than using all of these sort of spotting things and using these tricks. Okay, thank you.